I'm Joy Ebertz. I'm a principal engineer at Split, and today I'm going to be talking a little bit about some feature flag use cases that you haven't heard about yet. So before I get into all of that, who am I? So I like to write. I have a blog on Medium. I like to read, especially fantasy. I like to bake, especially pies, and I like to run, especially really long distances on trails. But that's not at all why you're here today. So who am I professionally? I still like to write. So on my blog, I do write about running, but I also write about diversity and inclusion, as well as purely technical topics. I've worked at a few different places now. I'm currently at Split, like I mentioned, but I previously worked at Box for quite a while, and I've also worked at a tiny startup and at Microsoft. I'm a backend developer primarily, mostly working in Java these days. I have done a lot of work on splitting monoliths into microservices and microservices architecture in general. I've done a lot of work around writing clean REST APIs and putting together standards for those. And I've also worked a lot on authorization service, specifically, most recently on OPA, which is the symbol here. But today I'm actually going to be talking about feature flags, which is what my company Split does, which is how I know a lot about those as well. So we're going to go through a little bit of what are feature flags in general. I know this isn't quite what the topic said in the title, but I want to make sure we're all on the same page and we all have the same background before I get into some of the more specialized use cases. Those are going to be removing dead code, checking parity, evaluating tech costs, and then some load and stress testing, all using feature flags. So first of all, what are feature flags? Some other terms for them that you may have heard include feature toggle, feature flip, feature switch, conditional feature, and at Split, we like to call them splits. But basically, all of these terms basically refer to the same thing, which just means that you have code that branches and they're based on a GUI interface where you can control what happens. So what does this look like? You have a block of code that might look something like this. So this is what the Split code might look like in Java. And basically you're checking if the treatment's on, then you're going to do one thing, and then you have a different code block in case it's off. And then in the UI, you might have something like this. So you can say, if a user is a QA tester, or if the user is in Boston, then they want to see the on treatment. Otherwise, give them the off treatment. And this maps to the code. Basically, those first two groups, the QA testers and the people in Boston that I mentioned, hit that first code block, and then everyone else hits that second code block. So you can change what happens based on this. So what are some of the standard use cases? First of all, releasing features, and then there's production testing. So basically making sure that your features work in a production environment without affecting everyone. ABC testing. So I include the C here because sometimes you have more than two different options you're evaluating. You might have 3 or 4, but you being able to test various options on something and seeing what performs the best. Custom packaging. So maybe you have a premium package for customers who pay you more and you want to give them extra features that other people might not have. So you might be able to use it for something like that. And temporary UI customization. So this is something we offer where you can actually do something like if you have an outage in Boston, you could show a little message in the UI that only shows up for the people in Boston. And then it says, like expect delays, we have some problems right now, or whatever it happens to be, right? So being able to do some things like that. I'm going to go a little bit deeper into that releasing features one and sort of walk through the full use case there. So basically, this is around separating deploy from release. And what I mean by that is separating when you actually take your code and push it to the cloud and allowing that to happen at a different time from when the user sees a new feature or sees like new UI or, gets the actual changes. So how does this work? So basically, you have a user who hits your server and asks for a whale, and it's going to return a whale, right? Now you have a developer who comes in and like us pesky developers do, we say we can make a totally better whale. So this developer is going to add a new whale, and they're also going to add a feature flag in front of it. So now when that user comes, we're first going to check the status of that feature flag. And since it's going to initially be released as off, it's going to go ahead and say, oh, we're going to still fetch the old whale, and they're still going to see the old whale. So nothing has changed. New code is on the server. The user sees nothing different. Now, later on, we can have a product owner come in and change that flag from off to on. And now at this point, when that user comes back, and the flag is checked, they're going to go ahead and get that new whale back. And so now, assuming everything goes well, everybody's going to get that new whale. And then the developer can come in and delete that old whale as well as the feature flag. So they can clean out that old code. And now it's only going to be left with the new code. So this can also be done instead of just on off, like I mentioned. You can also do something like roll it out to 10% of users and make sure nothing goes wrong in that process. And then you can slowly ramp that up to 20%. And if suddenly something does go wrong, pretty much all feature flags, but especially our product, has some sort of kill button, some sort of automatic, just like shut this off button. And we actually have a big red button in the UI that says kill. So if something's going wrong, you can immediately turn off the feature flag. And so then it's no longer going to be serving the on treatment. Okay, so that's the basic use cases. That's what most people know about feature flags. So what about these advanced use cases that I mentioned? So the first one is using feature flags to remove dead code. So before we even touch that, real fast, why is your code dead? It's probably what you're asking right now, right? So the most obvious answer is that you have a method somewhere that's just no longer referenced anywhere. You might think that your IDE can help with this, and it can catch a lot of this, but it's not going to always get this. And there are certain languages where this doesn't really work as well. So that's one option. Another one is that you have an endpoint that's never actually called, right? Like you have an API endpoint that people used to call and just no longer do, or maybe you implemented it and like forgot to tell anybody about it. So nobody's ever called this thing. And this is also where some of those methods get hidden too, because it may look like they're referenced, but they're not actually getting hit because the endpoints that are there are not actually calling them anymore. You can also have an if or block in your code, or a switch statement or something else, right, dependent on certain parameters, and you just never pass in some of those parameter options, right? So it might be that the Boolean you have there is just never false. Every single method that calls it is always true, and that's also pretty hard to catch. Right, so as you can see, there are a few different ways where you might have blocks of code that just never get executed. The obvious solution to this is to stick in a log statement, right? So just stick in log statements in every single one of those blocks of code. When I was at Box, we actually had a script that would do this. So you could run it from the command line and specify a file, and it would just go through and figure out all of the logical blocks in your code and stick in one of these log statements with a different UID, right? So that you could end up with you could identify which lines were getting hit by checking your logs later. The problem with this is, as you can easily imagine, you could end up with many, 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 many logs, especially if you're just going through and trying to add these statements all over all of your code, right? And if you've worked at any of the places like I have, you'll know that logs can be very expensive. And I've definitely spent time trying to clean up logs, trying to limit our logging so they're not paying so much. And I'm sure a lot of you have as well. So you don't quite want to just do that. So what can you do instead? So what we've done is we've wrapped this in a feature flag. So now we can check this feature flag, and if it's on, then we're going to log. And if it's not, then we're not going to log. And how does this work? So with this, we can now, instead of just rolling it out and letting it log until we happen to remove that statement again, we can instead just turn on the split to only, let's say, even 1% of traffic, and leave it that way for even as short as 30 seconds, and then turn it back off. So we're going to go ahead and roll it out, turn it back off, and then we can go through our logs and see which lines were hit and remove those, because anything that got hit at that point is going to get hit a lot, right? And so that should get the most hit lines of code. And then we can sort of repeat this process, right? So you roll it out again, leave it on a little longer, or roll it out to a few more people, and then remove the log lines. And you keep doing this, and it should slowly get out the most hit things until you're left with only things that either aren't used at all or are only very, very rarely hit. So at this point, you can just roll it out to 100% and leave it here, as long as it makes you comfortable, checking your logs every so often, right? Maybe this is a couple of weeks, maybe this is a couple of months, maybe this is a year, whatever it is, depending on what your product is and how important it is to make sure you don't delete functionality, right? So leave it here until you're comfortable removing it. And then at this point, any of those log lines that are still there, that code is never getting hit. So you can go ahead and remove that code and remove that code, right? Because you can assume that it's dead. So now we have a nice clean code base. Okay, so the next use case. Now we're going to use them for testing parity. So typically when you want to test parity, you have some old system and you're trying to replace it with some new system, right? And you want to make sure that to the end user, they're not really seeing a difference. So you want to have your requests come in and out of the old system initially. And what you're going to do is you're going to send an async call over to this feature flag parity check thing. And it's going to go ahead and call the new system and get the result back from that. And then it's going to check whether what the old system responded with matches what the new system responded with, right? So with this async call, we went ahead and also sent what value the old system thought it should be. So at this point, we can check the two of them. And if they're different, we can log it, right? So we can say, oh, these don't match. We're going to go ahead and log this. Again, the reason to do this behind a feature flag is also still because logs are expensive and we want to add a filter here. So we can do it such that we're not logging all that often, or maybe we might just turn it on because we're not expecting any differences. But as soon as we start seeing logs show up, we can go ahead and turn off that feature flag so we're not continuing to log when we already know there's a problem and we know what it is. This is actually something we did at Box when we were rolling out a new authorization system, and we found an entire class of authorization checks that we had totally forgot to handle. And it worked out fine because we never rolled anyone off of the old system. Everything was still responding the way it used to, and we were able to fix the entire problem before anyone saw any differences. So we were able to prevent an authorization problem without any users being affected. An example from Split, this is something we're actually working on right now. We have some code that we're switching from an old database to a new database. And so we have two splits for this case, actually. We have a write split and a read split. And in this case, so first of all, initially they're both pointing to the old database, right? So we're only writing to the old database, we're only reading from the old database. And then at some point we can turn the write feature flag on for both databases. So at this point, we're going to be writing to both the old database and the new database. And now we turn on the feature flag for reading to both. And at this point, we are pulling the data from both the old database and the new database. And again, logging if it's different. And I've made these look the same. They're actually completely different data stores in our case. So this allows us to catch, are we writing the data differently? Are we reading it back differently? Anything in the middle? And I actually skipped the step of the migration, but did we miss something in the migration from the old database to the new database between the writing to the new database and once we're starting to read from the new database, right? So it allows us to catch a whole bunch of different problems that we might have by adding this parity check. Yeah, I guess I already talked through the authorization service example here, but essentially, again, you can call a separate service even and check whether the results are the same or different. Actually, we're doing the same thing at Split as that we did at Box. It's a little different technologies, a little different code base, but the same idea of wanting to check that the new service is returning the same result that the old service did. Okay, so that was a lot about parity checking. So checking to make sure that new systems match old systems. Now we're going to talk a little bit about evaluating tech costs. So in this case, again, we're probably going to have a new system and an old system, but instead of parity checking, we're going to just mirror the traffic, which mirroring is basically the same as parity checking, but without the checking portion of it, right? So in this case, we're going to go ahead and asynchronously send all of the traffic that was going to the old system to the new system as well. And how it's useful to have a feature flag here is because we want to be evaluating the cost of the new system. We can pretty specifically limit when we're sending the traffic to the new system. So we can say, we want to send it for exactly 1 week. And then we're going to, because 1 week is typical for a thing, and we can extrapolate from there. We paid X amount for that 1 week, so we can extrapolate that we can expect to pay, X times 52 for the entire year, or whatever the calculation happens to be. So this allows us to get some idea of whether the new system is actually going to cost the amount of money that we expect it to. There's a couple of ways you can do this. So the way we've done it is we actually had most of the code written for the new system, we had it basically ready to go, but we use this as a sanity check of like, is this actually going to be cheaper like we think it's going to be cheaper, or are we going to be surprised somewhere, right? So before we actually started moving traffic, we did this. You could also, if you had a way to more easily do a POC sort of thing, you could do this much earlier in the process. Instead of fully building out the new system, finding a cheaper and smaller way to just run the traffic through or whatever it might happen to be to get some idea of what the cost is going to be. So that's for calculating costs using feature flags. Another way is, so we're now going through other ways you can use mirroring essentially, but another thing is for load or stress testing of your systems. So with load testing, you basically just want to make sure that a new system can handle the expected load that it's going to get. So how this works is again with mirrored, and you might actually even start here with way less than full traffic. So I've put this like small dotted line here. So we've done this in the past where you just send like 5% of traffic to the new system because you don't know how your new system is going to behave and you don't know where the problems are yet. So it's a little easier to debug them sometimes if it doesn't just, blow up completely, and instead you just have some slow spots. So you can sort of work through and then send more traffic as it becomes better and better. So that's the idea here. Eventually you would get to the point where you could send full traffic to the new system as well as the old system. And you can continue to monitor this new system and like check the logs, check the dashboards, and make sure that it's behaving how you would expect it to behave. Now, stress testing is trying to max this out, figure out where the system is actually going to break. So if we add more and more and more traffic, where is it going to blow up? In this case, so there are a lot of tools out there, things like Gatling, things like JMeter, which you can write tests for those and they will just hammer your system. And these are really great ways to stress test a system. The big problem with them is that they tend to only test whatever scenarios you give them. And typically it's like the same things over and over and over again. So it's not going to give you realistic traffic patterns, right? It's going to give you a lot of traffic and it could be still usually going to be very useful results. Don't get me wrong. It's just not going to always be realistic. So where this comes in instead is we can do something where we start mirroring traffic, but we could actually even like double mirror it, right? And you can imagine you could even delay one of these mirrors. So with this asynchronous call, you can say, okay, send over the traffic immediately and then wait 5 minutes and send over the same traffic again. Obviously, there's a few problems with this as well. You might have more error cases for things like being able to create an object with the same name, for example, in our case would create an error, things like that. But it should give you at least a more realistic picture of what traffic might actually look like in your system. And some of these error cases are legitimate too. So being able to know that you can handle all of that kind of stuff can be useful. So that was a whirlwind through a bunch of different feature flag use cases. Hopefully you learned something. And I just wanted to leave with one other thing. So if you're looking for a feature flag use case and don't already have one, like I mentioned, Split does feature flagging. So definitely check us out. The other thing I wanted to mention too, though, is we actually have an integration with Jira that we released recently. So with this integration, you can tie your feature flags to Jira issues. And this means that within Jira, you can see, for this issue, what feature flags are linked to it. And you can also see the status of those feature flags. So is it rolled out to 5% of people or is it fully rolled out? Similarly, in the Split UI, you can see which Jira issues are related to a particular feature flag. So you can see that a feature flag might have 20 issue tickets related to it, or maybe it's only one. And you can also see what the status of those are. So oh, rolling this flag out is blocked on, these 3 issues, things like that. So it's a great use case for both products together. And with that quick plug, I will leave you. Thank you.